the developments in the standard. Who have we got? We've got quite a few, which is good. I guess because there's quite a few people, I mean, I don't mind if people wish to ask questions as we go. If there's not too many, I'll try to answer them along the way. Otherwise, we'll get going. The agenda that I've put together today is to look at, firstly, what actually is AS 3008, and I would hope that most people have probably got a pretty good idea. And I've got my copy of the standard with me. There'll be a lot of references to certain tables and in the standard, so it'll be handy to have the standard with you if you don't already have it. Why is it being revised? And I think it was important to make note of what has not changed, just as much as to discuss what things have changed within the standard, because you know, that's I think is equally as important. What are the major impacts of the change, and when is a standard due for publication? What is 3008? Selection guide. Hopefully everyone's aware of this one. The selection guide for low voltage cables up to 0.61 kV. It's a legally mandated standard because it's called up in the wiring rules AS 3000. And there are two parts of the standard. Part one being the standard is based on Australian standard conditions, you know, things like ground temperatures and air temperatures and so on. And part two being the New Zealand standard based on New Zealand conditions. There are tables of current ratings within the standard, which cover most of the standard cable types using either PVC insulation, XLPE. There's also tables for current ratings of bare conductors, and included variety of installation conditions such as in air, exposed to sun, and so on, and underground type installations. The standard also has lots of other useful cable performance data like cable reactance, AC resistance, and voltage drop factors. Why is it being revised? I guess the first point here is probably what was the case maybe 5 years ago. Standards Australia used to have a policy to periodic revision of standards. Today, standards usually get revised when there's a need to, when there's a major, you know, changes are needed, and that has to be supported by a project plan and have the appropriate financial justification to revise the standard. Why else do standards get changed? In this particular case, there's a need for inclusion of modern cable selection methods, which I'll go into a bit more. Obviously, fixing errors. Occasionally, you get errors come up. You know, when the standard gets published, and we fix some of those. Some of the things we changed in this particular version of the standard was to create better clarity on a lot of issues. And as I said, the standard is almost ready for publication. It's in its final stages, so it's not far away. Firstly, let's look at what hasn't changed. The tables of continuous current ratings continuing to be calculated according to IEC 287. That's the international European standard for calculation of current ratings. No change there. The cable designs that we calculated the ratings based on, they haven't changed. So the dimensions and all those sorts of things, cable types, conductor types, they haven't changed. So so that's probably an important thing to know. There are only a couple of exceptions where the IEC 287 hasn't been used, and that is cable surrounded by thermal insulation, for example, where there's an empirical method used to determine those ratings. We're continuing to publish two separate documents, so we're maintaining what we had before in terms of the two separate standards, one based on Australian conditions and one on New Zealand conditions. And I thought the other thing that was important to mention was we're maintaining the fundamental difference between, say, crosslink materials, XLPE for example, and thermoplastic materials. And what I'm talking about here is with the almost, what would you call it, uniform migration to V90 PVC. Users of the standard might think that they can use the X90 tables of ratings. Well, you can, but under certain requirements, and those notes already existed in the standard, and that allow you to use PVC cables at the 90-degree ratings. And I guess what I'm reinforcing is that the same notes are still there, and the same distinction still exists. I mean, cross-link materials will always be thermally more stable than thermoplastic materials like PVC, which is why the standard distinguishes between the two materials in the tables of ratings. One of the main reasons for undergoing this process of changing the standard was to introduce economic cable sizing. This is a modern cable selection technique, which I briefly stated before, and the principle is not new. It's been introduced in the IEC 287 series way back as far as 1995, and it's a principle based on offsetting the cost of losses. For example, when current flows through a cable, heat's generated and there are losses associated with that. So that is offset by using a larger conductor size, so you can save on losses, but you might have to pay more for the cost of a bigger cable at the onset. But payback time can be quite quick, and you know, there's been lots of papers written on this subject, and we've decided to include it in this particular standard by way of a worked example in Appendix 9. And I've written there, it's an informative, so that means it's not mandatory. So if people wish to adopt this technique, they can, but it is not mandatory. The mandatory requirements are, as you're probably all familiar with, that cable selected according to continuous current rating, voltage drop, and short circuit rating. There's a minimum safety requirements. They're the mandatory requirements, and this particular selection method is an informative, which is non-mandatory. So that people know, you know, where to go to in terms of pointing to Appendix A9, where we've introduced text references in the scope of the standard and a new clause 2.6 under the selection process. I've written about this particular subject matter in an article I did last year. If you want more detail on how to do this particular perform this particular calculation or selection method, you can refer to that article I did last year. So that was one of the main reasons for revising this standard on this particular occasion. Some of the other things we looked at in revising the standard, and what happens when you go through the process of revising a standard is you have industry consultation and you get feedback from the industry, and in this particular example we saw the need to introduce different configurations for single core cables. This is in one of the appendixes at the back of the book. Appendix D, there used to be just the one table D1, which was intended to cover single core cables that results in both good load sharing and low magnetic fields. So what we've done is introduced a new table, an additional table to D1. So if users wish to focus more on reducing magnetic fields of single core cables, then we've introduced a second table. They're slightly different configurations, so we'll look at the tables in detail when they come out to make sure they're understood properly. There's what we did when we looked at introducing the second table. We did some investigation to check for the validity of it, and things like separation distance of cables and the actual current that's flowing in each parallel group, things like that do tend to upset the balance of things. So, you know, there's some guidance in there as to, you know, where the configurations are valid to. Some of the other sort of more subtle things that we looked at, defining what a circuit is, and when you're trying to work out what derating factor to apply to groups of cables where there is mutual heating, it's important to understand what a circuit is. So we've introduced definitions, and I'll put them there. Multi-core cable, you have to have 2 or 3 cores carrying a current. Groups of single core cables, and I guess one definition of a circuit that may be not as well known as a single cable, for example, that causes self-heating. So if you've got multiple turns of cable wound on a drum, each one of those turns is deemed to be a circuit when applying the appropriate derating factor, for example. So we've just added information about defining what a circuit is a bit better, so that we know how to apply the right derating tables. In line with this new definition, we've changed some of the headings. If you look at tables 3, 1, 2, 3, and 4, for example, they used to be called derating tables for more than one circuit. We've changed that a little bit to just say derating table, because really the derating tables of 22 and 23, they need to be applied even for single circuits. So it's not just appropriate that they're applied for multiple circuits, and I use the example of cable installed on perforated trays. That's where you need to look at tables 22 and 23 for the appropriate derating factor for just a single circuit. So there's some subtle things that maybe people didn't quite realise, and what we try to do is to improve the clarity in those areas. Some of the other areas that we've added some clarity and provided extra guidance is cables surrounded by thermal insulation. We've tried to improve the definition of what means partially surrounded, what means completely surrounded, in an attempt to align with AS 3000 in its definition and AS 3999. So, and I'll just quickly jotted down how we've defined them. So, and it relates to the distance that a cable is surrounded by thermal insulation. So, if a cable is completely surrounded for more than 400 mil, and obviously the longer the distance a cable is in a poor thermal environment, the less likely there is for longitudinal transfer of heat. So, so if it's more than 400 mil and it's completely surrounded, then you have to use the totally surrounded rating from the tables of ratings. But if it's not 400, if it's between 150 and 400 mil and completely surrounded, you don't have to use the totally surrounded rating. You can use the we've deemed that to mean partially surrounded. So important in terms of understanding these, to know which particular column of the tables of ratings you should look to find out how to apply the rating for these installation types. And the last one, if it's a very short distance, for example, less than 150 mil, then you really don't need to derate at all. So a normal unenclosed in air rating will apply to any cable that's surrounded by thermal insulation for less than 150 mil. Okay. Some of the other things we looked at were, and again, this came from industry consultation. When you look at a lot of the cables of performance data that's in the standard, and look specifically at reactance values for single core cables, those values are only applicable to cables that are touching, whether that be trefoil or flat. So we wanted to introduce some way of allowing people to work out reactance of cables if the spacing's not touching. So we put in there some correction factors which you just simply add to the values of tables, and we put in half cable diameter spacing, 1 diameter spacing, and 2 diameter spacing, for example. And what we found when we looked at this is that in providing extra guidance, we noticed that for small conductor sizes, say cables less than 25 mil, there wasn't a great influence, so you need not have to adjust the values if the spacings were a little bit larger than touching, if they were half D or 1D. So we found that the error was quite small, so we just added that guidance to just make it easy for people to use the standard. I talked about reactance for non-standard cable spacings for single cores, and this is the follow-on from that, and that is, what do you do for the voltage drop factors for non-standard cable spacings? And what we've basically done is, for all of the tables of single core cables, that is the voltage drop factor tables, and I've listed them there. If you have non-standard cable spacings, then we advise people to determine the voltage drop value by using the modified value of reactance. So what you've got to do is go back using clause 4.3 in the standard under the voltage drop section, and use the adjusted value of reactance to determine a new voltage drop factor. So we've tried to give people the right method of adjusting even the voltage drop factor for cables that are in non-standard spacings. Some of the other things we looked at, we noted that products like LV-ABC, XLP insulated aluminium and copper twisted aerial cables weren't really covered properly, I suppose you could say. So what we did is we added, weren't covered properly because there weren't columns for 80 degrees C for things like AC resistance. So we added columns for 80 degrees C because that's the temperature, maximum operating temperature that these products are rated to. When we added columns for both copper and aluminium. But to avoid any confusion, what we did was we limited the range of conductor sizes to just those that are in common use. So, for example, copper aerial bundled cable, we only put in the values from 6 to 25 square mil, and for aluminium cables, we went from 16 to 150 square mil. And so that people, could quickly find out where they had to look. We added suitable notes to the table, giving people guidance that these are the values that are appropriate for LV-ABC. Did the same sort of thing with three-phase voltage drop. Before we had AC resistance, but now we've got three-phase voltage drop, again for LV-ABC. Similar sort of thing. Needed to add some columns for tables 40 and 43 for 80 degrees C, again aligned with the operating temperature of the cable. Columns for both copper and aluminium, and the same sort of thing with the sizes relevant for these product types. So it really just follows on from the previous slide for ABC. Now that we added that information for LV-ABC in the right tables, we had to delete some 80 degrees C columns from tables where it's not really needed. So that's what we've done here. So columns 8 and 9 of tables 45, and columns, same columns from tables 50 and 51 have been deleted, just so there was no confusion that people might think they've got to use those tables for LV-ABC. It's not the case. And the reason why they're removed from here is that, well, when you look at the way an LV-ABC is constructed, it has thicker insulation than, say, a standard cable made to AS5000. That's required by the relevant standard for these products, AS3560. So really, the better cable type to base the values on is that associated with single core cables. So that's what we've done. Added some notes and make sure that people know where to look for the tables appropriate for LV-ABC. A couple of other things that maybe sort of went under the radar a bit. I mean, we have tables of ratings for flexible conductors, and they were in the last revision of the standard, but for some reason there was no AC resistance values for things like a single core 630 flexible copper. So we added that to the table 37. Seems a bit innocuous, but it's something that's it is commonly available in the industry, so we see the need to add it to this revision of the standard. So I think hopefully you're getting a feel for, some of these revisions are not they're not really radical changes to the document, but they're more like enhancements and we're trying to add clarity and direction where we see needed. What other things have changed? This is an interesting one because this is associated with applying the derating factors for multiple circuits. I've got the picture there of multiple circuits on cable tray. What we found were some anomalies identified with the derating factors in table 23. 23, what's it used for? Finding the derating factor for grouping of single core cables in air on cable trays. Why? Due to the influence of the tray itself. They can restrict circulation of free air around the cable, and also you need to apply derating factors for cables that are in close proximity to each other, regardless of whether they're on perforated or unperforated tray or whatever. So the next slide sort of gets into a bit more about what the anomalies are that we looked at. So what we found is that if you take the example of an unperforated tray, if you looked at the standard, look at column 6, and this is relating to table 23. Column 6, row 1 was a derating factor for 0.95 for a single circuit, whereas column 6, row 12 was also a derating factor, but it's 0.98 also for a single circuit. So it's a bit odd that you'd have the same derating factor, different derating factor for the same configuration. So we looked at trying to remove these anomalies, because in reality those two situations are exactly the same, just because they happen to be I think one was horizontal oriented trays and one was vertical oriented trays. I mean, they're both single circuits, so they should have the same derating. So we looked at fixing those sorts of anomalies across those the values in that table. They're not huge changes, but there's some really small, subtle differences. So that's really the main sort of summary of the changes that occurred in revision of the standard. And like I said, the main impetus was the economic selection. Economic sizing was introduced into the standard, and we fixed up a lot of anomalies and created extra guidance along the way. So there's not, like I said, no great radical changes. Maybe people will be comforted to know that the main tables of current ratings have not changed. But at the same time, yeah, like I said, we introduced cable sizing on economic grounds and things like the installation methods that give reduced magnetic fields. Only the last thing I was intending to talk about was, when is it due for publication? Well, we're right at the very tail end of the process, and it'll either be published in 2016, which we're near the end of at the moment, or very early in 2017. So it's not far off at all. So hopefully everyone's got something out of it. I haven't seen any questions come up. If anyone's got any questions, I'm happy to take them now. Okay, I'll notice a question about things like 3x3 arrays of conduit, and that's a fair question. That's a very complex thermal environment, and there are other standards that do include derating factors for such installations. ERA document 6930, for example, that does deal with arrays of conduits, and I guess if if that's the sort of thing that users of the standard would like to see in the document, then we can certainly look at including those in in future revisions. That wasn't something that the industry fed back to us. So, but if it's needed, we'll certainly have a look at including that in the next revision. But ERA 6930 is a good reference for complicated situations like that. I'm reasonably sure a copy of the webinars get uploaded to the Voltimum website, so that they can be viewed at a later time. And I've also written an article along the same topic, and that should be published on the Voltimum website in the next few days. If there's any more questions, I'm free to answer them. There's usually the question about the Voltimum article and other publications. I think that's one to ask the people at Voltimum whether that's a possibility. No problem. I certainly appreciate your thanks with regard to the webinar. We had quite a few people register, so I was very encouraged to see a lot of interest in this standard. Now, there's one question coming here about related to I think the question there about the thermal insulation relates to let's say when a cable gets installed in a roof space and there is currently no thermal insulation, but it's 150 mil above, and whether that will have to be deemed to be surrounded by thermal insulation. That is probably not within the scope of this document. I would say that sort of clarification should be in AS 3000. So I would guide you to that document, which is also in the process of being revised for clarity on that particular issue. I mean, this particular standard is, I guess is more about once you define, how, the type of installation, then the standard allows you to determine what its rating is. This question is more related to, trying to determine how to classify the installation first. So I think that's mainly associated with AS 3000. That's probably the better standard that clarity will be seen in. Now the next question is about switchboards where there are multiple ladders stacked above one another, but otherwise the issue of stacking cables on multiple ladders and that sort of thing is quite complex, particularly when this can also be above enclosures that are generating heat. Becomes very complicated. If they're big cables, and you're concerned about considering the influence of, say, the switchboard and the heat that's in there. The length that this hotspot, for example, might exist has an impact. If it's relatively short, and when I say relatively short, if it's only half a metre or a metre, then typically you don't need to worry about it too much, because there's sufficient longitudinal flow of heat to avoid having to derate. But I guess, you know, if one is concerned about things like switchboards that are generating heat, I'd probably install some temperature monitoring devices, longitudinally, and finding out whether you do have a hotspot at all. That's probably the best way to determine if there is an issue. And then once you know what the degree of heating is, then you can derate appropriately. Oh, yeah. Something's happening in my mind. Might as well scroll down. No, you haven't lost the sound. I'm still here. There's a question about DC ratings. Very interesting. We did think about adding guidance for DC ratings of cables. The general rule is that the DC rating is less onerous than the AC rating. So if you were to assign like the AC current rating to a cable, the DC rating will always be better. In reality, the difference is insignificant at small conductor sizes, and only really gets up to about 10% when you're talking about 630 square mil. conductors. So only when you get to the big sizes is it significant enough. So, and we did think about that, and that's another thing that I guess is on the agenda for the next version, whether we introduce some extra guidance on DC ratings, because it is certainly something that's very topical and very popular in the industry today. I've just been pausing just to see if there's any final questions. I don't see any at this stage. But I'm certainly still available if anyone has any. We normally have a questionnaire to a feedback questionnaire to for attendees to give us feedback. I'm just trying to find out where that is. Yeah, thank you for your attendance today. I think I'll close this down, and we'll see if there's a questionnaire. No polls. What's a poll? Oh, that's not what we want.